Today we're covering 10.2, lines tangent to a circle. First thing we need to talk about is what is a tangent line. When you have a circle and a line, a couple of things that can happen. You can have that line go straight through the middle of the circle and it would intersect the circle in two places. You can have a line outside of the circle, which means that it doesn't touch it at all. Or you can have a line that intersects the circle in one place, and that's called a tangent line. This is the scenario that we're going to talk about today. So a tangent line, it intersects the circle in one point, which means again it stays outside the circle and it touches the circle in one place. A new theorem, if AB is tangent to circle C, remember this is the symbol for circle, at point P, then AB is perpendicular to the radius. So they're saying that if this is tangent to this circle, then it's perpendicular to this radius. So if we know that this is tangent, we know that this is 90 degrees here. So again, this is the radius. So tangent lines are perpendicular to the radius. The converse is also true. So if we know that it is perpendicular, then we know that this is a tangent line. Let's look at an example. This is try it number 2. The first question, it says, is PM tangent to circle C? Well, what we just said is if this line is a tangent line, then it means that this is perpendicular. This is a radius. If you look at the picture in your book, it might be a little bit clearer for you. So if this radius and this line is 90 degrees, then that means that it is tangent. If we look at this triangle, NPM, we know that triangles have to add up to 180 degrees. So if we take 180 and we subtract 58 and 33 from that, that tells me what this angle is. And we're looking to see if that angle is 90 degrees, because if it is, then it would be a tangent line. When we subtract this out, that unknown angle, this angle is 79 degrees. So that means that it is, it's 89 degrees. Because it is not 90 degrees, that means that this is not perpendicular, which means that this is not a tangent line. So the answer to this question is PM tangent to circle C. The answer is no. Look at the second question. It asks you to find the length of K to N. This one's a little bit more complicated, but still using the same idea. So we need to find Kn, and we're going to use the idea of a right triangle. The biggest thing you need to realize with these kinds of problems is radiuses are all the same. So if this length from the middle to a point on the circle is 9, then from this point to this point on the circle, or the middle to the point on the circle, is also 9. So when you look at this triangle, this is your hypotenuse, and these two are the legs. So I'm going to set that up using the Pythagorean theorem. One leg is x plus 5. That's this one. This leg is 9. And this entire leg is x plus 1 plus 9, because we're looking for this entire length. So that ends up being x plus 8. All I did was add these two things together. So now I'm going to simplify this and figure out what x is, because in order to find the length of LK, Kn, in order to find this length, I need to figure out what x is, then I can plug it in and find out how long that line is. So what I'm going to do first is FOIL, and that's just a real quick first, outer, inner, last. X squared plus 5x, your middle terms gives you plus 10x, and then 5 times 5 gives you 25. 9 squared gives you 81. Same thing on this side, I'm going to FOIL. If you're uncomfortable with that, rewrite it twice so that it's easier for you to FOIL. I'm doing this quickly because we're recording to make it go a little quicker. That's my first. My outers and my inners both give me 8x. When I combine them, I get 16x. 8 times 8 gives me 64. On this side, when I clean this up, 25 and 81 gives me 106. All I did was clean up that side. Now I'm going to start moving things around because I could possibly be factoring, but bottom line, I need to figure out what x is. So if I move everything to the right side, when I move this 8x over, or this x squared over, they cancel each other out because x squared minus x squared is 0. It's gone. When I move this 10x over here, 16x minus 10x gives me 6x. So I dealt with that. And then when I subtract 106 and put it over here, 64 minus 106 gives me negative 42. And I have 0 on this side. So this is just like a two-step equation. Move my 42 over, divide by 6, and I found that 7 is x, or x is 7. When I plug that back in, this length right here, if x is 7, then this length is 6. This length is already 9, so this entire length of kn is 15. Biggest thing you have to be careful about is those radiuses. Be careful that you don't see that this entire length is not x minus 1, it's just this length here, and you have to add that radius. Continuing on, this is try it number 3, and they're asking us to find yz. They're asking us to find this length here. Looking at the picture, these are both radii. They're showing you that they're the same, and they're both 12. They're marking that, but we also know that all radii are the same. And in order to find this, we know that this is perpendicular. If this is 20 and this is 12, we're asked to find a leg of a right triangle. So if you redraw it, it would look something like this. So this is 12, this is what we're trying to find out, and this is 20. So it's basically just like what we did in the past with the Pythagorean theorem. So we're going to plug in 20 as my hypotenuse and set that equal to 12 squared plus x squared. This is something that we've done before, so this should be a pretty easy problem for you. Subtracting that out, we end up with 256. And then square rooting, that gives you 16 for x. And because x we identified as this entire length, then yz is 16. Be careful that when you solve these kinds of problems, like we've said before, there's a difference between if you're looking for x or if you're looking for the entire length. In this case, x represented that entire length, so we didn't have anything else to do here, and we're done. New theorem. If two segments with a common endpoint exterior to the circle are tangent, then the segments are congruent. So if I know that this is a tangent and this is a tangent, remembering from the beginning of the video, I know it's tangent because this line meets this radius at a 90-degree angle. I know this is tangent and this is tangent. Because of that, I know that these two segments are congruent. So both of these are tangent, they're meeting somewhere outside the circle. That means that this length and this length are the same. So we have to know that they're tangent in order to know that they're the same. And this is basically saying what I just said. Let's look at it, try it 4. This one's a little bit more of a complicated picture, but it is applying what I just talked about. Take a look at this section here first. So this line and this line is what I'm referring to. So we know that both of those blue lines are tangent because they meet the circle at 90-degree angles. Because they meet the circle at 90-degree angles, I know that they're tangent. They meet at an exterior point, which tells me that both of these segments are the same. Down here, the same idea. I know this segment and this segment are the same. If you look at your picture in your book, it might be a little bit clearer. This picture is actually kind of difficult to draw. I did the best I could. But looking at the idea that this is a tangent and this is a tangent because they meet the circle at a 90-degree angle. They meet at an exterior point, which tells me both of these segments are the same. And if I go around, you'll see that all the way around. I know that this segment and this segment are tangent because they meet at 90-degree angles. They meet at an exterior point, so they're both congruent. Same thing over here. This line is tangent, this line is tangent because it meets at 90 degrees, meets at an exterior point, so they're both congruent. So it asks us to find the perimeter. We're going to add 2 plus 3 plus 3 plus 6 plus 6 plus 7 plus 7, and that total perimeter is 36. So big ideas today is the exterior, or the tangent meeting on an exterior point, they're congruent. And we also talked about if a line is tangent, it has to be 90 degrees to the radius. So two big ideas today, know the two theorems that we talked about. Homework is posted on the notes and also along with the answer key.